I was wondering, does anybody have I was about to ask Leonard, but he's been sick. How much rain we got over the last 24 hours? Because it feels like we had a good half inch. I'll ask him anyway. I don't know if he's on. I'll see if he's on. But school is back. We have the second largest entering class that we've had in 30 some odd years, which is a mercy actually, because we didn't have as much of a housing crunch this fall as we had last fall. But we did house them all last fall without unnecessarily putting people in triples. Our president is very firm that if the room was not designed for 3 people, it is not going to have 3 people put in. So, all right. And yeah, so the university's in the middle of constructing the HSTEM building, which is being built alongside, like right into the ChemSci building. And so all of my poor chemical engineering faculty members got relocated, and they're now in cubicles up on the, like, I don't know, 6th or 7th floor of chemistry. And but they get first dibs on the new building, so they kind of get to choose their office once that opens up. What else is going on, Pasi, on campus? The students are back. I mean, it's a nice bumper crop. You know, they're still wandering around in shorts and sandals.
Yeah, for another 3 months. Once it goes to the sub-zero, they might give up.
Yeah, the men are the last to give up, is what I've noticed. First, they give up on sandals, then they give up on shorts.
Right. I think everybody's just waiting for the US 41 to be done.
Oh man, tell me about it. Yeah, so that's a good point. So last summer, from starting from late spring all the way into, you know, I don't know, end of October, they did one way of what they do. They did eastbound, right? They did of Highway 41, and now this summer they're doing westbound. And so you can still go westbound through town, but they put you on the leftmost, you know, aisle. And so guess what eastbound has become? Houghton Avenue. Yeah. It's a major highway. I have semi trucks going down there at 25 miles an hour, and it's pretty impressive. All right, so I'm going to get ready to show my slides. And I'm getting rusty on this. I haven't done this in a while. And I'm going to answer a few more questions. Hi, Debbie from the East Coast, Maryland. Good to see you. All right, John Baker is a card-carrying member of the California State Railroad Museum and has been for over 25 years. So there you go.
All right.
So one of you might know him. That's right, Mike. And last week we had career fair with over 350 companies. And if anybody wants to set up a hotel in town, they're going to make good money. I'll tell you what. Hi, Bob and Nelva. Great to see you too. All right, and now I owe you some cookies, you guys. They sent me Jan Hongels, and this is one of my new Dutch words that I've been learning. And I owe them cookies. All right, I'm going to share screen. You can see what I'm seeing. So tell me if you can see my slides.
We can, not the slideshow. Okay, there comes the slideshow. Okay.
All right, and I'm going to go back. There we go. I'm ready for an almost on time start. So I'll give it a few more seconds. So I have to share, I got this really cool mug from Bruce Coffer, who came up here to give a talk about railways and renovating one of their steam engines this summer. And that was really good fun. All right, so I think we're ready to go. So I would like to begin by just thanking everybody for joining us. You are joining Michigan Tech. This is what we call Husky Bites. We call it Husky Bites because it takes place during dinner time, at least on the East Coast, that is, or it's during your ride home if you're kind of on the West Coast, and lots of people join us from all over the US and the world. Welcome back if you're joining us again, and welcome if it's your first time joining us. My name is Janet Callahan, and my role at Michigan Tech is I'm the Dean of the College of Engineering. And it's hard to believe this is my 5th fall, or as we say here, it will be my 5th winter. It's actually season 6 of Husky Bites, which we started in summer of 2020 in the midst of the pandemic. We kind of launched it for other purposes. We kind of wanted to help people understand that you could learn things remotely, even though, in my opinion, it's not ideal. And then what happened is we just kept going as long as we have lots of people joining us. So thank you, everyone who's joining us. It wouldn't be any fun without you. We also live stream through Facebook. We post these afterwards. So if you ever miss one, you can catch up. If you don't do Facebook, you can join us through Zoom. One of the advantages of joining via Zoom is that you're able to ask questions using the Q&A feature. And one of the disadvantages is you kind of have to register to get a Zoom link. And that's kind of how we help keep kind of weird Zoom people out. All right, so it's time for our first poll. Polls have become kind of a trademark of some of these things. So I'd be curious about who is joining us today. And so you should see that a poll has just been launched, and it's going to look like this. So can you guys see this? Can you see the poll as it's being filled out?
Yep.
So
Yes.
A very diverse audience. We've already got 159 people joining us live. That'll grow probably up to about 200, I'm guessing. And we can see lots of people are used to answering the questions. So we have a lot of people who attended Michigan Tech. Yay! Go Huskies! And then some students, some friends of Michigan Tech, some family, some curious people, and some people who work here. So thank you for filling out the poll. Next up on my slides, I wanted to show some pictures of the sunflowers. So the sunflowers are a tiny bit of a story. I'll make this short. So during the pandemic, I just started growing sunflowers. I can't really explain it, but I did. So we also sent some people as prizes some sunflower seeds. And so apparently they were supposed to be dwarf plants. And so Jim has grown, this is one sunflower with all those flowers there on the left. And I think he wins the prize for most flowers on a plant so far, because, and very, very beautiful plant, and nice shirt as well, Michigan Tech. And then Dan is going to send me some updated kind of pictures of the flowers, but you can see right here in the middle one, that's going to be a huge sunflower, and it already is. This is a picture he sent me a while ago, and he had to, I asked him, how did he measure the size of the sunflower? And I don't know if you'll be able to see, but this is already 12 to 14 feet. And so these are, he was at 12 feet plus and 9'4" on the other two. So he's going to send us pictures that I'll show you next time. And mine, I don't know if I can effectively show you this. I might not be able to. All right, come on, change slides. Look what I'm doing. There we go. So I wanted to show you the menu of who is going to be featured this fall, and what we have is, of course, tonight's talk, and then I'll say a little bit more about next week's talk. But then we have everybody from electrical and computer engineering through chemical, through some Huskies pet band students and Michael Christensen. We're going to do some kitchen metallurgy, and I'm a little bit worried that it's going to cause marital spats, but we'll tackle that when we get to it. And then John Vustich out of CFRES, the College of Forest Resources and Environmental Sciences, is going to speak about restoring the balance. Carolyn Duncan, who studies falling, will be speaking on November 14th. And then we'll close the season the Monday of Thanksgiving week with some geology. And it's our favorite faculty member, Bill Rose, with co-host Erica Vi. And that will be our season end of season 6. And then we'll start back the Monday after after I think it's Martin Luther King Day. So that's our lineup. And if anybody happens to want to sponsor one of these, all of the money sponsored goes directly to student scholarships, and you're welcome to do that. But if you're already giving to Michigan Tech, that's fine. Just keep doing that. And then up next, you're going to really like this one. It features one of our mechanical engineering faculty members, Paul Van Susante, and some students in the Multiplanetary Innovation Enterprise. And you'll be very interested in hearing about. Thank you, everybody, for joining us. And this is my reminder: if you would like to ask a question, type them in the Q&A feature, which you can find if you navigate your cursor down to the bottom. You should see a Q&A field, and you just type them in, and we will do our best to answer all the questions that are asked. And now I would like to introduce, and Pasi, you can share your slides. Dr. Pasi Lautala, and I'm only going to give a brief intro because he's going to say a little bit more about himself. And co-host Eric Peterson. And so I met Eric in Indianapolis with his wife, Pat, and it was really nice. That was during an alumni reunion, an alumni gathering. And if you would like one in your area, just let us know, and I will reach out to Jen, and we will try to arrange one in your area. But Pasi is a faculty member in the Department of Civil, Environmental, and Geospatial Engineering. He is the director of the Rail Transportation Program. He's quite interested in the energy efficiency of rail, which we all should be. And originally from Finland, he is an alum of Michigan Tech, having earned both his master's and PhD here. He is the son of a locomotive engineer, and I actually think rails kind of ends up showing up in your bloodstream based upon what I've been learning about rails lately. So with that, Pasi, I'm just going to turn it over to you to say a little bit more about yourself and to further introduce Eric, and take it from here.
Okay, well, thank you, Janet, and thanks for giving me and Eric this opportunity to bring you 200 years of transportation. So it is going to be kind of rapid fire presentation today because, as I said, we have 200 years to cover. We were trying to debate what should we really discuss when it comes to the rail, but in the end we thought that, you know, there's a lot of folks who obviously have seen the rail on the sidelines and so on, but haven't necessarily lived it either in the industry or been closely involved, as not so many of us in the US keep riding the rails like maybe in some of the other countries. So we decided that we're going to try to cram it all in. So this presentation is probably going to be moving faster than most of the trains in the US. So I'm not going to do a big introduction of either one of us at this point. We're going to kind of get to that as part of the presentation. Instead, I'm just going to turn this loose, and that means I'm going to turn Eric loose. So Eric Peterson, one of my great friends and colleagues from the industry, is going to start telling us where did we come from with the rail transportation since it got started. And with the questions answered, I'm going to try to kind of look at them here on the way, but we're going to be coming to them in the end. We'll try to make sure that we rally through this and we have some time for discussion and answering in the end. So without further ado, Eric, get started. Where did we get started?
Well, the railroad industry, the technology is what is unique, and it was really needed for transportation about 1825 in the UK. It got started, and by 1930 it was started organized in Baltimore, the Baltimore, Ohio Railroad, the first common carrier railroad in North America. And believe it or not, I worked for this same company in 1974 as part of Chessie System Railroads. So why does it work so well? And it's really a civil engineering solution for basic transportation. The rail is supported by the ties, and the ties spread the load, making for a smoother, faster transportation corridor possible. And then when you start connecting multiple cars together, it certainly is a much better means of transportation than wagons pulled by horses And the wagons used to sink into the mud and things like that. So that's how we got going with this. So one of the things as rail transportation expanded in North America, and one of the big events was completion of the first transcontinental railroad in 1869. Trains had to operate based on timetable schedules based on some kind of clock system. There was no other communication. So standard times were established, and that lets you know what time you need to go to the station to get on board a train. Later, the invention of the telegraph provided communications and made possible more flexibility. 1920, railroads were the primary transportation mode until the automobile and trucks became viable in the 20s. They were the biggest business, and some abuses led to extra strict regulation. This was the peak time for the size of the railroad network. In the mid-1960s, 3 railroads operated in the copper country. Calumet and Hecla was the mining railroad. The Copper Range Railroad and Sioux Line Railroad were both serving the area as common carriers. And the Sioux Line operated a passenger train with the Milwaukee Road overnight, providing overnight passenger service between Chicago and Calumet. The Houghton Hancock Lift Bridge was constructed 3 different times to serve railroads as well as highway traffic, and streetcars or interurban electric transportation also used the bridge for a while.
All right, and just like we do in our classes, we want to make sure that the students are actively participating. So this is your first chance to participate. We just kind of want to get an idea, how well do you know the history in Houghton? When was the last passenger train? When did it depart Houghton? So you have 4 options, 62, 68, 73, or 78. So let's see who has the best memory or recollection out of this. I see the answer is coming in really quickly, by the way, so a lot of folks seem to be knowing it. Right now, 68 is leading by pretty large margin. Okay,
At least they're paying attention, Pasi.
Absolutely. Yep, 1968 got the biggest vote, so I'll turn this back to Eric to talk about that.
Yep, 1968 was the end of an era. Here's a picture of the Houghton Sioux Line passenger station with a crowd to greet the train, and many people took a ride to Chassel that day. That building still exists down on the waterfront near the Houghton Library. The Copper Range Railroad Station also still exists and is reopened as a restaurant with many railroad historical displays inside. I was on campus that summer for surveying and met my future wife, Pat, that year.
On the train?
No, the train was gone. Yeah. Yeah. So a little bit about myself. I graduated from Michigan Tech with a civil engineering degree in 1970. I stayed for a master's in business that I could do in 4 quarters in 1971. I left Michigan Tech and went to work for AutoTrain, a startup of a special train service with cars and passengers on the same train between Virginia and Florida. That original company did not survive, but Amtrak purchased all the assets and later revived the service, and it is their most successful service still today. I went on to work for the RF&P at Potomac Yard in Alexandria, one of the largest classification yards on the East Coast at the time, and then went to work for Chessie System Railroads with a variety of field and headquarters responsibilities over the year, including being a division engineer for a division. I then switched careers and went over to the signal and communication side, working in signal construction. was transferred back to headquarters. And later on, I was involved with our merger preparation projects for 1999, a big merger. We rebuilt in 18 months the railroad between Cleveland and Chicago. I later headed up signal design and construction. And my last job before retiring in 2008 was heading up public projects, where we dealt with all the state and local governments and anybody that wanted to build something near the railroad. And so that's my history briefly. Here's the map. And I was born and raised in the Detroit area and took a long trip, what I thought was a long trip at the time, to Houghton to go to school. After that, we left and went to the Washington, D.C. area, then on to Punxsutawney, Pittsburgh, Huntington, West Virginia, Columbus, back to the Detroit area, then Jacksonville, Florida, and we now live in Carmel, Indiana. So the railroad industry has had many ups and downs over the years. In the 1970s, while I was working at the startup of AutoTrain, rail transportation in the Northeast US was in trouble. Operation continued, and I was then working at Potomac Yard, the major East Coast classification yard. It was tense. Would the Penn Central bankruptcy, would Penn Central's not be able to pay their bills to other railroads and cause even more bankruptcies? Upper Michigan and the Copper Country Rail Service was also on the decline with the end of copper mining, and trucking competition favored in Michigan and other states, allowing larger trucks. Passenger service was substantially reduced and had been taken over by Amtrak in 1971, a government-supported corporation. Conrail was established in 1976 with government assistance to consolidate the Northeast bankrupt railroads. And by then I was on Chessie System Railroads on the Pennsylvania division. We looked at other line segments proposed for abandonment to see if we could profitably serve some of the customers. And the Staggers Act was next. Staggers Act was federal legislation to substantially deregulate the railroad industry. It was in 1980, it was a turning point. Railroads were then able to abandon unprofitable line segments, consolidate traffic corridors, contract markets based on rates, and as well as merge. I was in Huntington, West Virginia, working for Chessie System in managing our first computer system for engineering work planning, scheduling, and reporting. It took the industry 10 years to transform operating and business practices and become profitable with good cash flow and a business with high long-term capital requirements. By then, I was division engineer for the Ohio division, and in 1987, Conrail went public, and all the government support that had been put into Conrail was paid back. The key measurements here: productivity, volume, revenue, and pricing. You can see there just a substantial change in all these measurements. Unfortunately, after about 2004, 2010, many of these measurements have leveled out, and that is a current struggle within the industry. Today, North America needs to shift a lot more freight traffic to rail to lower costs, save fuel, reduce highway congestion and damage to pavements and bridges. The railroads are challenged to provide more timely service to match modern logistics. So also, as part of the Staggers Act, it was easier to merge, and mergers were done for providing mass. Today, there are about to be 6 North American Class 1 railroads. We have one more merger, Canadian Pacific and Kansas City Southern, expected to be completed later this year. There are many additional regional and short line railroads. So Kansas City Southern serves a lot of Mexico with a subsidiary and up to Kansas City, while Canadian Pacific actually connects all the way down to Kansas City. And so that's going to be a North American transcontinental railroad in Canada, as well as a north-south railroad in the middle of the continent. Canadian National has a somewhat similar layout, being connecting both coasts in Canada, but also serving north-south all the way to New Orleans in the United States. So, okay, Pasi. So this is the chart that I will not go through in detail, but it gives you an idea of the magnitude of the number of different railroads that have been merged into the 4 US railroads, Norfolk Southern, CSX, Union Pacific, and BNSF. So how do we compare in the world? Freight traffic can be, one of the ways to measure freight activity is in terms of ton miles. 1 ton hauled 1 mile. Also can be measured in ton kilometers, as you might expect. And it's not surprising the United States, Russia, and China lead this measure because of the long travel distances. That is where rail freight really pays off, when you can do long runs, but it can also serve relatively short markets.
All right, so we're gonna get you back to before anybody can fall asleep, we're gonna make sure that you're gonna be active. So the next question is, you just heard that we are using more freight rail than almost any other place, but what's growing the most? Is it coal, crude oil, chemicals and allied products, or intermodal? You guys are definitely awake, because the responses start coming in about half a second after I put them up. That is impressive.
Yeah.
I told you, Pasi, this is no sleeper audience.
Plus, they obviously know also what they're talking about.
Yep.
Anybody
And we-
want to take one of my classes on these topics? This seems like an easy class to grade.
Well, and what do you think? Are they right?
Well, Eric, what do you think? They keep voting for intermodal. More than half of the people say intermodal. Are they right?
Yeah, intermodal is one of the big growth areas, but I'm also pleased to see that they've identified growth in chemical and allied products as another good one for us. Coal has grown short term recently, and crude oil is always an opportunity. If we're not going to build pipelines, we're going to move it by rail. So talking a little bit about intermodal. Intermodal, it started out as trailers on flat cars, and it's become half the number of freight loads now. I looked at last week, September 10th through the September 10th, there were 223,000 car loads and 241,000 containers or trailer shipments. So that is a big part of the business. Transportation of trucks, trailers, and flat cars was a small activity for many years, as I said. It increased in the 1970s with dedicated high priority trains on key routes. The next big change was Sealand, an ocean shipping company, and they pioneered the use of containers for faster loading, unloading, as well as substantially reducing theft of ocean shipping traffic. Railroads adapted to include container-compatible cars. As demand grew and standardization of containers was established, railroads developed double-stack well cars, almost doubling the capacity in the same train length. Substantial capital investments have been made to increase clearances for the double-stack cars. These same 20-foot clearances are needed for full-height auto transportation rack cars for new and used vehicles. Tunnels, bridges, and other obstructions continue to be cleared for these 20-foot high cars on additional routes. One 2-mile long intermodal train can have over 150 wells or container spots And because it can carry too high, that means 300 containers or the equivalent of 300 trucks on one 2-mile long train. So now Pasi will discuss U.S. passenger rail service, the Michigan Tech Rail Transportation Program, and changing technology.
Okay, thanks, Eric. So as you may guess, the passenger side is not going to be as elaborative as the freight side is, because our system really is built based on freight. But we do certainly have passenger service in the US. Most are publicly owned and subsidized, unlike the freight rail, which is all privately owned. It actually was increasing before the pandemic. We had pretty much record high Amtrak passengers. We had close to record high transit passengers, and a lot of new and expanded commuter rail systems. I even started to see a little bit of glimmer for the high-speed rail operations, and then came the pandemic. So now the time will tell how they're going to be recovering out of that. Now, we saw the comparison between US and the world for freight. As you may guess, the story is quite different for the passenger side. We are much more towards the bottom than the top on the list. And part of the reason is that our system is just simply designed and built for freight movements. We don't really have necessarily high speeds and necessarily the best quality tracks, because freight doesn't need them. So it's hard to have very consistent passenger service if you don't design your systems for that purpose. As Eric mentioned, Amtrak handles most of the intercity traffic, and it was temporarily set up in 1971. That temporary is continuing today. They operate over 21,000 route miles, approach almost every single state in the US side, but often it may be only one train per day. It is kind of broken down between shorter distance state-supported services and then the long distance cross-country treks. But one thing to remember is that even with Amtrak, over 70% of all the travel miles are operated on the tracks owned by these freight railroad companies. So Amtrak doesn't really own their tracks. They just operate on their tracks and pay a very low fee for the hosts. So then the question that I was expecting to see in the chat, and I already have seen it, what about the high-speed rail? Well, if you want a high-speed rail, go to Europe or China or Japan, or live long in the US, because maybe it will be coming. Now, the truth is that you can find some level of high-speed rail. We've been having Northeast Corridor since 2000 between Boston, New York, Philadelphia, Washington, D.C. Correct, it doesn't run all the way high speed, but there are some sections that do run high speed. And Acela trains, Amtrak is supposed to be getting new Acela trains fairly soon. So I do recommend anybody who wants to taste a little bit of a higher speed train in the US, that will be the place to go in a couple of years here. There are some other ones like Pride Line in Florida, privately owned. It's a little bit different situation, owned by Virgin now, and eventually should be running between Miami and Orlando. We do have some higher speed trains in the Midwest up to 110 miles per hour. We consider it higher speed rail. The rest of the world would consider it just a regular passenger rail. And then there's the California high-speed rail. It is going to be the first true high-speed rail expensive system if it ever gets completed. It has a fairly hefty price tag, and the progress has been fairly slow, but it's still progress. And there's a lot of discussion in Texas as well. Remains to be seen. So that was pretty much in the nutshell of what has the rail history in the US been, what it is the rail today. So congratulations, you just got a grade on learning the basics of rail transportation in the US. Now comes the big question. Why are we still even using this method after 200 years? One of the big reasons is in this very highly engineering looking graphic. So all those non-engineers, you got to bear with me a little bit. It's a lot about efficiency. If you take a look at this graph, there are some lines or curves that kind of go pretty steep up. That shows the resistance of your water transportation if you start increasing speed. So if you take a look at about 40 miles per hour, you're really starting to creep up a lot of resistance from the water on the boats. If we look at trucks, it's a little bit better. We can get up to about 60 miles per hour, but the resistance is getting pretty high up there. So now let's look at the airplanes. Certainly, we can get a lot of speed on them, but the air really gives a lot of resistance up in the sky. So it's not necessarily the most efficient. Why does rail work? Because it can go fairly fast and the resistance stays fairly low. So why is that? Few reasons. First of all, steel wheel on steel rail. It's a very low rolling resistance. Some of you may have heard the question, how big is the contact patch that rail touches the wheel? Is it the size of dime, nickel, or quarter? This is not an official poll, but it is actually the smallest one of those. It's the dime. That's how much each rail is touching the rail if it's properly shaped and the rail is properly shaped. So it's not much. We have really strong vehicles and infrastructure, so we can carry really heavy loads. We won't crumple under 20 tons. And finally, multiple closely coupled vehicles called trains create a lot of low air resistance. When you combine those together, you're going to get a very efficient system. And I'll tell you, that is the main reason why we keep using the rail. So now you do get one more official poll question. How many miles can we move 1 ton of freight with 1 gallon of fuel? 260, 370, 480, or 590? And people are rocking in 3 seconds. I can't believe you even find those options that quickly. Looks like there's quite a bit of a fight between the last two options, 480 and 590. 480 is kind of creeping forward. All right, slowing down. I think by now the answer, the winner is clear, and the winner is 480. You guys obviously know what you're talking about, but let's take a look at this. Now let's give some comparisons. GM Hummer, you get 3 miles. You can move 1 ton of freight with 1 gallon of fuel for about 3 miles. Now, all those who have a Prius, as long as you can load a ton of freight on Prius, you would actually get 33 miles. Not too shabby. If we start loading these to semi-trailer, even better, 130. But obviously not even comparable to the rail. 480 miles, and at the same time, you can reduce your emissions by 75% from the trucks. So you can start seeing the reasons why a lot of the companies are actually very excited on moving more by rail. And it's somewhat true for passenger side as well, even though we don't have the comparison. You can still move them with a much lower environmental footprint. So that's kind of about the rail. So now we're going to jump to what do we do at Michigan Tech? And I guess that kind of starts with me. How did I end up here? As already mentioned, I was born a few miles away on the other side of the Atlantic, the little pond, 1972 in Tampere, Finland. I had my first railroad job with the VR or Finnish Railways 92. Yes, I'm a son of locomotive engineer, had no plans to have anything to do with the railroads as I become adult. I was supposed to be a professional athlete, but my back decided otherwise, so somehow I ended up in the railways. And they paid pretty good, so why not? 96, I got a great opportunity to come to US as an exchange student to Michigan Tech. Had absolutely no idea where I was coming to, especially had no idea that there was a bunch of Finns here. Ended up getting kind of stuck and finishing my master's at Michigan Tech, got my degree and thought I was going to go back to Finland, but a company called AECOM had different thoughts as they saw in my resume that I knew something about railways. So they hired me to help Eric and his partners with some of these CSX Conrail merger designs in Chicago. So I spent 5 years consulting in Chicago with AECOM and a little bit later with CH2M Hill. And a person who is on the call today, Bill Spruill, who was my advisor during my master's, he kept talking to me that, well, why don't you come back and let's do something on rail? So eventually I decided that let's take a little break on consulting, and I did my 6 months trip by train around the world, starting from Finland through Russia to Mongolia to China, and then not by train to New Zealand, but then around New Zealand and back, and finally came back to Michigan Tech, started PhD studies, and we started building something in rail. Didn't quite know what we were building, but by 2007, when I graduated, I guess we had convinced the industry and the university that we should really have a rail program. So we started it. So after that, I've been here leading the program and doing other things in the meanwhile. One thing I wanted to highlight, in 2010, I had quite an experience, went back to China with the National Geographic and a production company, and we shot a documentary called Megastructures, World's Most Extreme Railway, about the Qinghai-Tibet Railway. If you're interested, you can find it in YouTube. Fascinating 2-week experience in China, where I really felt like I was a movie star. I did get stuck partially in the copper country also, because I found the better half of me, Megan Packmeyer, and in 2012 and 14, we got our 2 rascals, first Olavi and then Ansel. And then 2018-19, we got a chance to go back to the home country and bring the boys to get to know the other side of the grandparents. We had a sabbatical there and perfectly timed it to get back before the pandemic and not in the middle of it. So that's my life in a nutshell. And as you may see, we do like to play some music and do some other things with the boys and the family as well. So now the more important part, which is the rail program. We started 2007 officially. I would say it's somewhat typical academic program, except that for us, railroads have very little visibility. So we really have strong events, extracurricular activities to try to get people to understand what rail transportation is and why is it so important, just like today for all of you guys. We try to develop leaders and technologies for 21st century rail transportation, have very strong industry connections. Eric was one of the first connections and who really helped both personally and with his company CSX to get us off the ground. CN has been a strong and solid supporter for us for about a decade now. We hope we make some impact. So far, we put about 200 students to work full-time in the railroad industry, railroads, consultants, manufacturers. We've introduced the industry for probably another 200 high school students through our summer youth programs, which is currently actually funded by the Federal Railroad Administration. And we've done about $10 million worth of railway research, or are conducting at the moment. And what I really like about it is that it's really diverse. It's not just me. We have 7 different project managers from 5 departments at the moment involved in rail-related research here. So it's been pretty fun to try to get people to apply their skills to rail. So now we get to the last little part of the presentation before we open this to discussion. We wanted to highlight some of the new technology. It is a 200 years old industry, but it has to keep on developing. Otherwise, it's just going to get stumped on the ground. One of the big advances railroads have is that a lot of the competing modes like vehicles and airplanes are trying to find alternative energy sources. Well, guess what? Electric locomotives, electric trains, we've done it for 150 years almost. Electric locomotives is nothing new. We have used regenerative braking. We've been feeding the power back, and we've been using different ways, obviously, to generate electricity for a long period. Unfortunately, we don't do it as much in the US, but still, that's a technology that we've used for a long time. However, there's now more discussion also on yet other alternative energies. Battery electric is coming back pretty strongly. They talk about the zero emission locomotives, and these dual locomotives are going to replace BNSF diesel units in Southern California, and they claim no emissions. Natural gas was really hard about 10 years ago when the oil price last time was really expensive. Not easy to implement. You need to build all the new systems. Hydrogen, California just ordered their first 20 hydrogen trains So hydrogen is becoming the reality already in the rail transportation. Not only alternative power sources, the other thing is alternative materials. Sometimes they are because of environmental considerations, like biodegradable rail and other lubricants that we use. Also, recycled materials using for the railroad ties, like plastic, rubber combined. Sometimes it is because of performance and productivity. Stronger, lighter materials using aluminum for the rail cars, or using stronger components like our knuckles. This is a project we are just starting at the Michigan Tech, where our materials department is looking how to make the knuckles stronger so they wouldn't be breaking as easily. Automation is on the word for everybody. We do have, there was a question, when are we going to start seeing automated trains? We already have them, not in the US. Australia has so-called AutoHaul. They run huge iron ore trains for over 1,000 miles completely without a driver, operator in the locomotive. They do it every day and all the time. That's for the freight side. There's quite a few subway lines for passenger traffic that operate without an operator. So we do have automated trains, and we should have them. It's a single freedom guideway, so it shouldn't be as complicated as it is on the roadways. Some of the newest things that are happening right now is there's quite a few startups looking into self-propelled rail cars. What if we didn't need a big train? What if we only want to be shipping one car at the time or two cars at the time? Intramotive, I just had a discussion with their CEO last week in Kansas City. They are looking to start moving commodities with their rail cars that can be moved, but can be moving literally on their own. Mining applications, maybe the last mile movements, couple of last 5 miles movements, short line or small, when you don't need 10 rail cars, so you can cut some of the operators away. Parallel Systems is doing something similar, but concentrating more on the containers and looking into those. I'm not saying these are going to be becoming mainstream anytime soon. There's certainly a lot of challenges and complexities, but they are being looked at on the rail side. Another area, new technology, is the inspections. Automated geometry cars and wayside detectors. It's required that you inspect tracks and equipment at the very regular intervals for safety purposes. Now they have automated geometry cars. Instead of people riding the cars, they just attach it to the train and haul it down the tracks. Some of these cars, actually, these cars in the picture were built at Escanaba by Escanaba Lake Superior Railroad, 3 hours away from Houghton. I just talked to CN, and I believe they said they collect 38 billion data points per week. I'm hoping that our culture computing, Tim Havens and those guys, can at some point start analyzing those data. I asked him, can we analyze 38 billion data points per week? He said, yes. So that's hopefully one of our areas that we're going to be expanding at the Michigan Tech. There's also other automated inspections, a lot of drones being used for bridge inspections. One of the technologies we've been working on is automating some of the grade crossing inspections. We have a crossing eye technology we are trying to commercialize with Mitri Inc. This is some of the videos that we've collected with the drones, and we can provide so-called view sheds automatically on approaching vehicles at grade crossings. Can they see the trains or can they not? Next thing is the communications. Positive train control is one of the requirements for any kind of train movements. You need to know accurately where the trains are. It's a train monitoring system. It's almost like automated braking for vehicles. If the engineer doesn't respond and it needs to be slowed down, the system will do it automatically. This is now implemented on most main lines in the US. The other side is the vehicle to infrastructure communications, how to warn, for example, drivers of grade crossings and trains approaching. We are working with the Federal Railroad Administration rail crossing violation warning system that literally brings these warnings into the vehicles. And if drivers stop on the tracks, it's going to tell them, get out of here. You don't need to be here. Or if they don't slow down when train is coming, it's going to say, you got to stop. It's also, we are looking at also how can we save emissions of vehicles, reduce congestion and all these aspects as a byproduct of this technology. So finally, to wrap it up, new rail modes. There certainly is also brand new technologies for passenger rail, probably for freight as well. What's going to happen after traditional high-speed rail? I think some of you have seen some of this. The Hyperloop. This was brought about 10 plus years ago by Elon Musk as the next groundbreaking new transportation mode that kind of relies on rail principles, but takes away a lot of things like air resistance. Well, I saw a presentation 2011 where they said that this is going to be operating everywhere by 2018. It's 2022. They have a couple of little test tracks, but they're still moving on. Magnetic levitation on the top right, that's in Shanghai, but it still hasn't been really working on a full scale in the world. But we'll see where they get. So to summarize, so today you've heard about 200 years young technology that is still not obsolete. It's still very much needed, and it probably is going to be needed even more because we do consider it is the clean mode of transportation because of the energy efficiency, capability of using alternate fuels, and the space and social impacts that we did not even get to touch today. Sorry, ran out of time. Michigan Tech, we are becoming one of the leaders of developing the 21st century rail transportation. And as we mentioned a couple of times, watch out, may get into your blood. So I'll end this right here. And I have not got a chance to really be watching a whole lot of questions, but I assume Janet has.
Well, and I'm just going to take one. And when I choose to answer it, I'm going to click on Answer Live. This question's from John. From a carbon footprint perspective, how does passenger trains compare to flying or driving?
There was actually a graph I almost pulled in but just so much materials. It certainly is on the lower end, but we always gotta look at a little bit with the grain of salt on when you do these comparisons, because it often really depends also on your distances and also obviously how many people are you moving with those. So if we compare like trains against, let's say, commuter airlines that run very short trips, it's going to be very favorable. Against passenger vehicles, it's probably going to be very favorable almost any time, especially if they're electrified passenger lines. But I don't think you're going to be seeing maybe as drastic differences as you can see on the freight side for the really heavy, really long movements.
Well, and Eric, please feel free to choose a question, but I'll choose one if you don't.
Okay, there was has PTC been successful for safety, or is it overly complex to add much burden to the rail operations? Yes, and yes. It was a $10 billion investment required by the federal government. It has been successfully implemented. And one of the things that's going on now is once we have this tremendous communications and location information infrastructure, how can we further use that to improve rail service, rail dispatching, and rail operations, and even customer information?
Well, and this is just a kind of a remark from Connie. The world's steepest railroad in the early 1900s was here in Ontonagon County. It was 20% grade on the river loop near Pori. The North Country Trail crosses this trailbed east of Gardner Road, north of Bruce Crossing. Porterfield and Ellis Logging R.R. Company ran this railroad. Just FYI.
Yeah. So there's so many questions that I'm trying to figure out which one should I try to answer first, because I could spend the next. Do you guys have another hour here to do it?
No, we're going to take about 10 minutes of questions. Just whatever you choose, click on Answer Live.
So okay, I see that there's a few questions about the hydrogen and why does it work for trains versus for the vehicles. I hate to admit, I wish that Andreas Hofrichter was here because he gave a really excellent presentation on some of the hydrogen aspects. But I think as of right now, the hydrogen locomotives and hydrogen trains number one, they are looked at mainly more for passenger traffic, where your power requirements are not as high. And also they are looked for more like, you could say, urban applications and somewhat shorter routes, so that you're able to get them fairly regularly into the charging stations. One thing you got to remember is, I'll go back to this, we are single freedom guideline transportation mode, which means that we go from place A to place B. We don't really go from place A to place B, C, D, E, E, F, G, depending on which intersection we take. So it's much more structured, the environment, which means that it's much easier to also size your, like, how much fuel you need and how much you have to carry and where you need your loading structures. Why is California going to the hydrogen? Because, as you may know, they're very aggressive in their alternative energy, and especially on the zero emissions energy modes in any transportation, not only trains, but also for the other modes. So I think California is going to be a lot the testing ground on how do some of these new technologies work.
All right, I can take on Tom Promota's question. What barricades are there to getting more truck freight on trains? Well, I think that that to its most extent is in the court of the railroads to offer services that match up with the modern distribution needs. There's tremendous investment that's already done in intermodal terminals, in intermodal freight transfer, especially in the port areas. And but the railroads have focused on making money, and they have not done enough, in my opinion, to go after new business in new areas. I think that's going to change. There's tremendous pressure from the existing customers to further improve service. And I think it's going to be a significant change. And obviously, if the cost of fuel stays high, it's getting everybody's attention, but it's got to be reliable. And railroads aren't always reliable and predictable on the freight side as they should be. They need to have capabilities, manpower, and locomotives to handle surges without dragging down the entire network when a bunch of traffic or a weather problem happens.
So I'm going to take a couple of more here, answer live. Do we ever see trains in copper country again? It's a possibility. I wouldn't really count on passenger trains, except perhaps some kind of tourist train, which I do think that there might be a value for that somewhere in the copper country. For getting a freight train back here, it simply would require big enough and consistent enough a volume of freight. And some of you may know that there actually is a fairly new service called, or new re-established railroad, Mineral Range Railroad in Eastbemming. It existed about 100 years ago, and it was restarted about 10 years ago by Clint Jones. And they are serving the Eagle mine, moving their concentrates from the refinery to the Eastbemming, then being moved by CN and others further. So it's definitely not unheard of that we would get more freight back to the, but it has to be big enough development and long-term enough. You got to remember that when you put money to the railroad assets, they are for very long-term. So you cannot justify doing with a couple of years of guaranteed traffic.
All right, I can take a couple here. The first one was Peter Eric asked about the model railroad equipment behind me. Yes, it's O-scale 2 rail. That's why we bought the house, to get this basement, and that's my hobby. I can run that railroad the way I damn well please. So what about higher speed freight? There is a history of higher speed freight already. And especially with the Western railroads, the Santa Fe ran some very expedited schedules for years. And Conrail was noted for their expedited intermodal freight across the eastern United States. So that is certainly a potential, especially in the container area. quickly get it loaded, unloaded, and moving. And it can be a very high pressure service from the railroad's point of view, but it can be effective. It's been proven to be effective.
So Pasi, you just typed in a question to Connie, to what Connie said about, what was the answer?
Well, she mentioned that there's trains that come to Lons twice a day, 7 days a week, and I don't think it's quite that frequent these days. It used to be, but I think part of the reason the track is a fairly low speed, so you can't move very fast on that track
Okay.
at the moment. There's a question: is there a distance when it makes sense to use rail versus over the road trucks? You know, again, it's not quite as simple as that, because it really depends also on what are your volumes. You got to remember, railroads are economies of scale. If we are only talking about 1 or 2 truckloads, even if it's a long distance, it's very unlikely that you would be doing it by rail, unless we get to some of these automated rail cars maybe in the future. But if you have a very heavy volume, low value, high weight, even short distances, let's give an example. Cliffs in East Birmingham and Negaunee. I mean, the mine, it only moves the iron ore pellets 25 miles to the docks and moves them to the ships. But there's absolutely no way they would ever do that by trucks, because they run three 120 car trains every single day. So it's a combination of your distance, the volume, the value, and all those aspects. There
Very
are some
good.
rule of thumbs that some people use. For example, for intermodal, they used to say that it only goes by rail if it's over 500 miles. I think even those have changed over the time. There's a lot of shorter movements now that move by train in intermodal. And it may not be because they want to send in intermodal. It may be because the truck drivers don't want to drive 500 miles. So
that's a point in Florida, especially because most loads, there's a lot more loads going into Florida than coming out of Florida. So there's a substantial part of intermodal traffic going into Florida because the drivers don't want to go in there for a one-way trip. Let's see what.
All right, one last question, and I get to choose it. This is from Bruce, Pasi, and Eric too. Why do you think passenger trains have an element of magic when we travel? They seem to set us into a different mode and state of mind.
I can definitely take this one. So as I said, I grew up in Europe, so I'm very used to riding passenger trains, and we still obviously do every time when we go back there. I really think that it's the comfort. And again, if you go to Europe or some of the countries that have higher speed and higher quality passenger trains, you'll really know the comfort. You may know it on some trains in the US too, but some of them may not be quite as smooth. Especially when you ride in a electrified higher or high-speed train, it's quiet, it's extremely smooth. I mean, I've gone 200 miles per hour and I have my coffee on the table or my cold beverage, BEER, on the table, and I can relax and I don't have to worry about it being. But at the same time, you still have more freedom than you have on the airplane or in the bus. You can walk around, you can go to restaurant, car, and you can, move your legs and all the others. I really think that it's the comfort that sets the tone while you can still be enjoying the views or doing your work or whatever you do.
Anything to add to that, Eric?
Well, I think Pasi's right. And I think there's also a different market out there. The Rocky Mountaineer service in Western Canada and now in the Western US out of Denver is a premium service with high-class service to take advantage of scenery and basically the ability to get away and be moving without having to drive yourself. We've done one trip and it was very enjoyable. So.
Well, very good. Back in season one, we used to run overtime, and right around season 2 or 3, I said, all right, we're gonna always wind this up by 7. So I apologize. We still have 27 open questions. We answered 41. But mostly I just really want to thank you, Pasi, and thank you, Eric, for your spending time with us, sharing your expertise. I learned a lot. I didn't actually fundamentally understand that plot you showed, Pasi, which showed kind of the resistance versus speed. I hadn't really appreciated that. So thank you, everyone. Thank you, audience, for joining us for Husky Bite. We'll see you next week. We're going to learn a little bit about mining in space, and I'll leave that on a cliffhanger. And if you were in a clear part of we are not here in Houghton. We have cloud, we have overcast, but apparently, what's the planet that's really bright tonight? Jupiter? No, Venus? It's a really bright night for one of the planets. You should go out and try to look for it if you have clear skies. And so with that, we'll hope to see you next week. We're starting our conversation at 5:45. So if you want to join, we don't actually start the quote unquote show until on the hour, but looking forward to seeing you, and really nice to see your, Eric, you should have had that going while you were talking. We would have all been staring at your train.
Well, it'd be noisy. It would sound like a real railroad in here.
All right. Good evening, everybody.
Very good.
Take care.
Thanks.